These are the Andes, fabled abode of the Sun King, the man-god known as the Inca. Home of his people and their legendary cities of gold, prize and plunder of the conquistadors. Their civilization was equal to that of the Romans in magnificence of cities, royal roads and bridges, engineering of irrigation systems, and in law, domestic tranquility, and assimilation of conquered peoples into the Inca Empire. All this is past. The Incas themselves were conquered and their empire fallen away. Only the Andes remain. Today, a new treasure has been found in the realm of the Incas. This treasure is oil, and it lies not in the Andes, but in the selva, the Amazonian jungle which even the Incas could not conquer. Climate and isolation have always precluded development of this area. The Andes to the west shut off access to the sea, and in all other directions lay the trackless selva. Even today, travel is by dugout canoe, and barge travel is possible with great difficulty. Only with the beginning of oil activity have a few miles of road been constructed on the periphery of the selva, despite extreme weather. Rainfall totals more than 250 inches a year. Yet several years of geophysical fieldwork indicated the possibility of an underground reservoir of oil of major proportions in this Putumayo region of Colombia. So convincing were these indications that despite the forbidding aspects of operating in such an isolated jungle area, Texaco and Colombia Gulf, partners in this Putumayo project, began drilling exploratory wells in early 1964. To operate in such a difficult area required many special techniques. Foremost is the complete support of the entire operation with helicopters. In this roadless jungle, everything travels by air. Since January 1964, Helical, the largest commercial helicopter operator in South America, has supported this Putumayo project for Colombia Gulf and Texaco Incorporated. This support begins with the initial exploration, when surface geology crews are dropped at convenient river sandbars where they are dependent upon the helicopter for supplies and a link with the outside world. Geophysical crews with their heavier equipment require more extensive support, especially fuel. With a well location chosen, clearing crews are brought in next, soon followed by an airlifted bulldozer for site leveling and preparation. Meanwhile, the rig destined for this new location is being dismantled and prepared for shipment. The move is planned to put rig components at the new location as they are needed. This time may also be used for maintenance and inspection of the rig. While the old location might be at an elevation of only 600 feet, the new location across 40 miles of tigre-infested jungle may be at an elevation of 3,500 feet. This jungle oil field airlift, moving staggering amounts of cargo and people in all kinds of weather, has become the world's most intensive helicopter operation outside of Vietnam. The magnitude of this operation is illustrated by the number of flights that just one rig move may involve. 300 flights to move the rig. Perhaps another 400 flights for accessories, housing, pipes, mud, chemicals, and personnel. Yet moves of several miles have been accomplished in as little as 4½ days from the end of drilling at one location to the start of drilling at a new location. Meanwhile, the drilling progressed to include the area just across the border in Ecuador. Based at Santa Cecilia, this operation was also supported by Helical through their subsidiary, Heli Ecuador. Within just 4 years of intensive exploration and drilling, the partners in this helicopter-supported jungle venture could count nearly 40 producing wells. Following this successful exploration and drilling program, sufficient reserves were indicated to begin field development and a production program. For these first wells have proven the Putumayo region along the Ecuadorian-Colombian border to be the most important new oil discovery in South America developed within the past several years. With the finding of oil, the problem then became one of getting it to market. Since barge travel to the east was not feasible, the only alternative lay in constructing a pipeline over the Andes, passing through the land of the Incas to the Pacific Ocean. Few pipelines are easy, but this Trans-Andean Pipeline promised to be one of the toughest anywhere. Starting at Orito, elevation 1,097 feet, the planned trocha, or right-of-way, 193 miles in length, crossed the Andes Mountains at an elevation of 11,540 feet, descending to the Pacific Ocean at Tumaco. To oversee planning and construction, Texaco and Gulf formed Trans-Andean Pipeline Company, with headquarters in the old conquistador town of Pasto. Hannibal Construction Company, a Williams Brothers subsidiary, was selected as contractor. As engineering progressed, a detailed plan for the pipeline began to take shape. It was to be a 100,000 barrel a day crude line with 4 pumping stations to lift the oil more than 10,000 feet above the beginning point in order to cross 2 ranges of the Andes Mountains. 5 pressure reduction stations would be required to break the hydrostatic push generated as the oil dropped 11,540 feet to the Pacific Ocean. Pipe sizes of 18-inch, 14-inch, and 10-inch were to be used to compensate for pressure gradients as closely as possible. At Tumaco, a marine terminal was planned with 4 225,000 barrel storage tanks. A 5th and final pump station was included to push the crude oil through 4.6 miles of 36-inch sea line to an offshore berth for tanker loading. In addition, a gathering station at Orito with 4 storage tanks totaling 16,000 barrels located at the first pump station. Concurrent with start of construction on the pipeline, a 1,000 barrel a day refinery was planned at Orito to serve the burgeoning petroleum needs of the Putumayo area. But a plan is not a schedule. By conventional methods, this could well have been a 5-year project. For example, from milepost 12 to milepost 60 on the right-of-way, no road existed or was planned. Steep gradients and unstable soil conditions, including one area known as the floating forest, made even the use of tracked vehicles extremely difficult. Yet it was planned to have the pipeline on stream by early 1969, less than 6 years after completion of the first well at Orito. Only then could Texaco and Gulf begin to recover their investment of $100 million. To meet this schedule, only 2 years could be allotted for construction. Obviously, a breakthrough would have to be found, some new method not bound by dictates of terrain and weather. The answer? Hannibal's space-age elephants, the Bell Huey helicopters of Helical. Selection of Hannibal was particularly appropriate for this task. A new Alps to cross, a new breed of elephants to ride. Beginning almost before day had begun, when the workers were delivered right to their jobs. To full day, when all supplies, parts, advice or assistance were delivered by air. To last light of day, when everyone was returned to camp. The job depended entirely on aerial transport by helicopter. In this roadless Andean country, many people have never seen an automobile, much less ridden in one. Yet to these isolated people, the helicopter became an accepted part of life. Perhaps their first introduction came when a superintendent from Hannibal Construction Company visited their humble schoolyard to meet with the people through whose land the right-of-way would cross. To others, like Manuelito and his pet pig Arnaldo, their first introduction was when a helicopter arrived at his mountainside home carrying tracks for a D6 Caterpillar bulldozer. As the components of the dozer were brought in, they were put in place, utilizing the Bell helicopter both as a transport vehicle and as an aerial crane during reassembly. This technique of leapfrogging bulldozers ahead, passing over other dozers, crossing rivers, bypassing obstacles, proved to be one of the most valuable contributions of the helicopter to the accelerated completion of the right-of-way. This vertical envelopment allowed one such obstacle known as the window, an extremely steep sandy ridge, to be attacked from above. Without the helicopter, it would have been a lift-yourself-by-your-own-bootstraps type of operation, where getting the first dozer on top would have involved a long and circuitous shoe-fly line off the right-of-way. Soil conditions were somewhat unique. Despite steep gradients and heavy rainfall, heavy jungle growth prevents erosion effects. After clearing, the deep sand with an overlay of clay becomes unstable, making it necessary to cut back into slopes perhaps 30 feet to ensure a 10-foot right-of-way. Because of these unstable conditions, more than 100 miles of right-of-way was rip-rapped. Logs were split and laid corduroy fashion side by side. In the Recorte section on the western slope of the Andes, where rainfall reaches the incredible total of 450 inches per year, rip-rapping was unbelievably difficult. It took 250 men 6 weeks to lay just 2 kilometers of riprap. It then became a reasonably secure footing for the tracked side boom pipe-laying machine. But getting the pipe to the right-of-way from the all-weather road, only 1 kilometer away, about 5/8 of a mile, was yet another problem. Even footings had to be carried in on workers' backs, a 2-hour trip. Nevertheless, enthusiasm was contagious. Once again, the answer was found to be Hannibal's new elephants, the gas turbine-powered helicopters of Helico. From hookup, lifting a 44-foot, 14-inch diameter steel pipe weighing 1,900 pounds, the helicopter made a 1-mile trip to the right-of-way, placed it down carefully, and was ready for the return trip in about 1 minute. After making several trips, the pilot touched one skid on the ground only momentarily, picking up lifting cables dropped with the pipe, keeping the job moving. Before the pipeline was finished, out of some 25,000 individual pipes comprising the entire project, more than 6,000 were airlifted and stockpiled at 1 kilometer intervals along the right-of-way where ground transport was not feasible. Representing a tough combination of factors, heavy load, high temperature, and a long distance to transport, was the lift at Orito of an 18-inch diameter, half-inch wall thickness pipe. At a ground altitude of 1,000 feet, lifting the 44-foot, 4,300-pound steel pipe was no problem, despite temperatures in the humid 90s. With pilot plus 1 passenger, and with 500 pounds of fuel on board, the Belle Huey carried the pipe 14 miles at an average speed of 80 knots. Interestingly enough, the pipe will usually stabilize at 90 degrees to direction of flight. Touchdown was at an altitude of 2,600 feet, with temperature near 70 degrees. Although helicopters did many jobs normally done by other types of vehicles, it should be noted that some means of transport in the region would still be familiar to the conquistadors. But no mule ever worked in weather like this. It's all in a day's work to these aerial workhorses. The Guamways camp at milepost 12 was the end of the road for supplies and pipe, and the beginning of the airlift up the eastern slope of the Andes. But the camp was completed and functioning long before the road ever reached it. Everything came in by helicopter airlift. Gravel for the concrete foundations of the second pump station. Dynamite, case after case of it, to blast out footings for a pipe bridge over the Guamways River, or to carve a slender right-of-way out of Andean rock. Diesel fuel for every bulldozer operating up on the right-of-way. Miscellaneous parts. And last but not least, food. Farther up the line, the Carmen camp at milepost 35, elevation 3,200 feet, was to remain completely isolated except for helicopter transport. These buildings were flown in ready for occupancy, and with lifting slings still attached, were ready for the next move whenever needed. Locations like the Carmen camp are a testimonial to the trust men place in the reliability of helicopter service. Despite some of the most rugged terrain and severe weather in the world, it has always been the policy of Helicol, the helicopter operator, to keep their ships in the air 12 hours a day, from first light to last light of day. This reliability is a product of the inherent quality of their Bell helicopters and of Helicol's superb maintenance program. Shortly before dusk, all helicopters return to their bases. As soon as each ship is on the ground, crack maintenance people begin their work. These daily inspections and light maintenance are performed at all bases, while at the Santa Ana base camp, all classes of inspections and maintenance are performed. Records in all classifications of inspections, all maintenance performed, aero civil, and component records are on permanent file at the Santa Ana base camp. But records and procedures are only as good as the technical ability of the men doing the work. All of Helicol's key maintenance people have attended factory training schools in the USA. Additionally, in-company training programs are conducted. To back up this technical ability, $500,000 of spare parts are available within the project area. To people not in oil field or pipeline work, this might seem to be quite an investment just for spares. But it has proven its worth for a project located deep in the jungle, 2,000 miles from any other source of spares, whether it be for helicopters or dozer, where a $100 million job is vitally dependent upon having every helicopter airborne every minute of the day. These few American-built helicopters, their Colombian pilots and maintenance people, have together piled up a record even a railroad would be proud to own. 255 million pounds of cargo hauled, equal to a freight train over 1,800 boxcars long, each carrying 140,000 pounds, or in terms more familiar to an oilman, 7,727 oil field hauling trucks, each with 33,000 pounds of freight. And still get 300,000 people to work on time. Many names have been given to this age. Among these is the age of communication. Certainly, communications are vital in this jungle and mountain region. Few would care to venture far into it without the reassurance of radio links with base camp and the availability of a helicopter for quick evacuation for a sick or injured fellow worker, or to reroute a helicopter to obtain needed drilling mud or lost circulation materials, or to retrieve some small but vital item. As the helicopter is a necessary part of all this, it becomes a communication technique itself. No other device makes possible such intermingling of previously isolated people. Having broken the bonds of isolation, this helicopter-assisted petroleum activity is just the beginning of greater things for southern Colombia. Any advance by man must first start with an inspiration. But inspirations grow out of seen or shared experiences. It may well be these very children who will bring this advance about. What they are seeing today will be raw materials for their dreams of inspiration. Just as the Andes were the inspiration for the Incas and their achievements of civilization, today it is the accomplishments of the Trans-Andean and Putumayo projects which are the sources of inspiration for the inhabitants of the old Inca Empire. With the aid of new techniques and modern tools like the helicopter, the petroleum industry has made another conquest over impossible obstacles in its never-ending search for 20th century treasure. This treasure is oil, an indispensable element in modern civilization throughout the world.